Humanity's first ever telescope called Galileo was so basic, it showed fewer details than a kid's toy telescope today. Yet, that simple tube of glass cracked open the sky for human eyes. About 400 years later, we've built Hubble and the James Webb Space Telescope. Two machines so powerful, they've redefined our place in the universe. So let's put them head to head and find out how these two compare. The mission. Back in 1990, we strapped a giant telescope to a rocket and tossed it 350 miles above Earth. That was Hubble, and it only had one mission: get above Earth's blurry atmosphere and finally show us the universe in sharp detail. For the first time, humanity had a camera in space that could stare deep into the cosmos without getting air in the way. Hubble fulfilled its mission and got us mind-blowing images of galaxies, exploding stars, and colorful nebulae that rewrote astronomy textbooks overnight. The James Webb Space Telescope, on the other hand, isn't about pretty pictures. Its mission is simple: to tell us about the history of the universe. Instead of focusing on visible light like Hubble, Webb sees infrared, which is invisible to us. Why infrared? Because it can cut straight through thick clouds of cosmic dust and pick up faint light that traveled over 13 billion years. That means Webb can capture the glow of the very first galaxies born. If Hubble gave us the middle chapters of the universe, Webb is turning pages all the way back to chapter 1. Technological advancements. Hubble's original computer memory was just 2 megabytes. That's smaller than a single photo on your phone today. And yet, it gave us iconic discoveries: the age of the universe, the accelerating expansion of space, and jaw-dropping views of galaxies. The technology was cutting edge in the late 80s. Its cameras, detectors, and spectrographs could split up light and analyze the chemistry of stars and galaxies. Webb's tech, by contrast, feels something out of science fiction. It carries 4 main instruments, including NIRCam and MIRI. Webb can detect incredibly faint heat signals, but to work, it has to stay colder than negative 230 degrees Celsius. That's why it carries tennis court-sized sun shields to block sunlight and keep it frozen. If Hubble was a precision camera, Webb is a cryogenic infrared laboratory, an observatory built to read the faintest whispers of light from across time. Wavelength coverage. This is one of the biggest differences, and it is easy to picture. Hubble works mostly in visible light, the same kind our eyes can detect, plus some ultraviolet. That's why its pictures look familiar to us, almost like enhanced photography. It shows space the way our eyes would, only sharper. Webb, on the other hand, is tuned for infrared. That's the kind of light our eyes can't see, but our skin can feel as heat. Why does it matter? Because the light from the earliest galaxies has been stretched or redshifted. By the time it reaches to us, it isn't visible anymore, and it's infrared. Webb was built to catch that light. Think of Webb giving humanity night vision goggles for the universe. Mirror size and design. Hubble has a 2.4-meter solid glass mirror, polished with incredible precision. When it launched though, a tiny flaw in the mirror made its image blurry. A flaw astronauts later fixed by adding corrective optics. But Webb's mirror is in another league. It measures 6.5 meters across, almost 3 times as Hubble's size. But it couldn't be launched as a single piece. Instead, it's made of 18 hexagonal segments, each coated with a thin layer of gold to reflect infrared light. In space, tiny motors move each segment, aligning them with nanometer precision. It's like a giant eye built from puzzle pieces, perfectly assembled a million miles from Earth. Location and orbit. Hubble orbits Earth at about 350 miles altitude, close enough for astronomers to reach it with the space shuttle. That's how NASA was able to repair and upgrade it 5 times, extending its lifespan by decades. Webb, though, is parked at a completely different location, the second L point, or L2. That's 1 million miles away, about 4 times farther than the Moon. It's a sweet spot where Earth and the Sun's gravity balance just right. But it also means Webb is unserviceable. No astronaut can reach it, and if something breaks, there's no repair mission. Webb is on its own. Launch and deployment. Hubble's launch was relatively straightforward. The space shuttle carried it up, deployed it, and once the mirror flaw was fixed, it worked beautifully. Webb's deployment was a nerve-wracking high-wire act. Because it had to be folded to fit into the rocket, Webb spent its first month in space slowly unfolding solar panels, antenna, sun shields, and mirrors. Over 300 single points of failures had to go perfectly, with no second chances. Engineers called it the most complicated space deployment in history, and somehow, every piece worked. When Webb's mirror finally aligned, astronomers celebrated like they had just landed on another planet. Age and legacy. Hubble has been working over 30 years. It's practically a legend, producing over 1 million observations and more than 20,000 scientific papers. Its legacy is secure. The Hubble Deep Field, the pillars of creation, and the discovery that dark energy is accelerating the expansion of the universe all come from Hubble. Webb is just getting started and was launched in 2021. In its first year, it confirmed galaxies that existed just 320 million years after the Big Bang. It detected water, carbon dioxide, and even complex molecules in the atmosphere of exoplanets. While Hubble mapped the universe we could see, Webb is showing us the universe we never imagined. Repair and maintenance. Hubble was lucky because it was nearby. Astronauts could visit it 5 times to swap instruments, fix parts, and upgrade cameras. That's why Hubble has lasted so long. Webb doesn't have that luxury. It's too far away for a service call. Every part of Webb had to work right the first time. Its lifespan depends on its fuel, which allows it to stay in position at L2. NASA estimates it can last 10 years or more. But once its fuel runs out, Webb's mission will slowly fade. Cost and investment. Both telescopes come with eye-watering price tags. Hubble's total cost, including service missions, has exceeded $16 billion over its lifetime. Webb cost nearly $10 billion just to build and launch. But the investment wasn't just money, it was global. NASA, the European Space Agency, and the Canadian Space Agency all contributed. These telescopes are not just national projects. They are international symbols of what humanity can achieve together. So, what's the verdict? Hubble gave us vision. Webb gives us depth. Hubble showed us a universe filled with galaxies. Webb is peeling back the curtain to show us how those galaxies began. From toy-like telescopes to these billion-dollar marvels, one thing hasn't changed: our hunger to look up, to push further, and to see the universe not just as it is, but as it was in the beginning. Let me know what you think in the comments below. And as always, thanks for watching.